Dear students, today we will be talking about trigonometric functions. Basically, we will be talking of domain, range, and graph of trigonometric functions, which is very important because when we are aware of the concept of trigonometric functions, we'll be able to understand the concept of inverse trigonometric functions very easily. To quickly understand the concept, first of all, we have to understand the concept of domain and range. So, domain means all possible values that we can put in x. For example, if I'm talking about sine x, so what values can be filled in x is basically the domain of the function, the angles, right? And then when we talk about range, that means all possible values of y is equal to fx. What we mean by that is when we put x is equal to 0 degree, then what is the value of sine 0 degree that we are getting? Yes, it's sine 0 is 0. So the value of sine 0 gives you 0. So 0 is the range of the function. Similarly, if I put x is equal to 45 degrees, then sine 45 gives you the value of sine 45. What is that? It's 1 by root 2, right? So we'll be studying 6 trigonometric functions and their graphs. Basically, my concentration is to understand the domain and range of the functions, right? We know this is the graph of sine x, as you can see, right? So what is the domain and range of this function? See, we can put any real value into my x, into my angle, right? So my domain is all possible real numbers. But when I'm talking about range, so we all know this is 1, this is -1, and this is. So graph of sine function, as you can see, lies between 1, -1 to 1. So what is the range of sine x? -1 to 1. Moving further, talking about cos function, cos x, this is similar. We know that sine 0 gives you 0, sine 90 gives you 1. In the same way, when we talk about cos 0, it gives you 1, and cos 90 gives you 0, right? So you know the concept, right? So when we are talking about domain of cos x, similar as we are talking about sine function, same goes to cos function. The domain of cos x is all possible real numbers, and the range of cos x is -1 to 1. This is your 1, and this is your -1. This is the 0, right? Moving on to next trigonometric function, which is tan x, right? Now here when we talk about tan x, let's understand it. When we talk about tan x, we mean sin x upon cos x, right? So when I'm talking about denominator, if I am getting 0 in the denominator, my function becomes not defined, right? Now here in this case, I cannot put denominator में I can't get 0. That means I cannot put x is equal to pi by 2. I mean 90 degree, right? Or I cannot put 3 pi by 2. I cannot put 5 pi by 2, right? So what will be the domain? All possible values except those values which give me cos x, I mean, the value of cos functions as 0. So at cos pi by 2, I am getting 0. At cos 3 pi by 2, I am again getting 0, right? We have already, you can see the graph of cos function. Here is the graph. This is your pi by 2. This is your 3 pi by 2, right? So that is why my domain for the tan function is going to be all possible real numbers, but not 2n plus 1 pi by 2. Why I'm writing 2n plus 1? You put the value of n. You put n is equal to 0, you'll be getting pi by 2. You put n is equal to 1, you'll be getting 3 pi by 2. You put n is equal to 2, you'll be getting 5 pi by 2, and so on and so forth. So domain of tan x is all possible real numbers except 2n plus 1 pi by 2. And what is the range? All possible real numbers, right? When we talk about cot x, we know that cot x is equal to cos x upon sin x, right? Now, when we are talking about cos x upon sin x, denominator we have sin x. So what value give me sin 0? Is the value of sin x as 0? Let's go back to sine function. Yes, here sin 0 is 0, sin 180 is 0, and then sin 360 is also 0, right? And sin minus 180 is also 0. That means I can say that n pi gives me 0, right? So that means domain of the function, domain of cot x is going to be all possible real numbers except n pi. You put n is equal to 0, you'll get 0. You put n is equal to 1, you'll get pi. You put n is equal to 2, you'll get 2 pi, right? And all these value gives you 0, right? And what is the range of the function? Definitely it's going to be all possible real numbers. Moving further, talk about cosec x. You all know this graph, right? You have already done your class 11. So when we are talking about cosecant x gives you 1 over sin x. So my domain is going to be similar to cot x, which is all possible real numbers minus n pi. And what will be the range? As per the graph, it is very simple to see. This is my y minus 1. This is my 1, right? So it includes, range includes all possible real numbers, but not the values lying between minus 1 to 1. So there is one confusion that is always created why taking minus 1 and 1 in closed brackets. We are doing this because minus 1 and 1 are the points which are touching the curves, right? So which are the range of the function. Moving further, we are talking about secant x. Now, when we are talking about secant x, it's 1 over secant is 1 over cos x. Okay, that means my domain is going to be all possible real numbers minus 2n plus 1 pi by 2. And the range is similar to cosecant x, which is minus infinity to minus 1, closed interval, union 1 to infinity, closed interval. So I hope all the trigonometric functions, their domains, and their range is clear to you all. This is very important. Why this is important, everyone? Because this is going to help you understanding the concept of inverse trigonometric functions. I hope the concept is clear. See you in the next video. Keep in touch.